Good morning, fifth grade. It's nice to see everybody's face today. Um, Please make sure that your cameras are on and you're with me kind of as we're watching this example. This is something that we've seen before. You're more than welcome to solve this problem using the distributive property that we talked about yesterday. Mr. Rachel's going to solve this by turning these into improper fractions. I think it's a little bit easier for me to keep track of, but there is some strength and value in being able to solve these problems multiple ways. So solve it how you choose, but I'm going to go ahead and get into it and read our problem. It says on Saturday, the orchard farmers picked 1 2/3 bushels of berries. Oops, I'm gonna go ahead and write that. On Sunday, they picked 5 1/3 times as many bushels as they picked on Saturday. How many bushels of black blueberries did the farmers pick on Sunday? That's what we're looking for. So I'm gonna go ahead and write our problem out, our two pieces of information. Whoops, make a big 5 right there. Okay, so we're looking for how many bushels of blueberries the farmers picked on Sunday. And we know that they picked 1 2/3 bushels on Saturday. So obviously Sunday comes after Saturday. So we're starting with 1 2/3 bushels and we're picking 5 1/3 times as many on Sunday. So obviously, 5 1/3 falls above 1 on our number line. So that means that our product is going to be bigger than our original number, which is 1 2/3. So our number is going to get bigger after we solve this. I'm going to convert these to improper fractions to start with. So let's remember how to do that. We have to multiply our whole number, so 1 times our denominator, or in this case, it's 3. So we do that. We get 1 times 3. And then we have to add that by our numerator. So we have one group of 3, which gives us 3/3. And then we have to add that by 2/3, our remaining fraction left over. After all that's said and done, we get 5 or excuse me, we don't get 5. We get 5 over 5/3. I believe that's our answer. So this is our improper fraction, 5/3. It's a number larger than 1. That's another way of writing 1 2/3. And we're going to multiply 5 and 3 right here. So our whole number times our denominator. We're going to get 15 when we do that, and then we're going to add the number on top, the numerator, and we'll get 16 when we do that. So we have 16 over 3. So we have 16 over 3 times 5 1/3. We have to multiply across, and then we have to multiply on the bottom in order to get our answer. So 5 times 16, I don't know what that is off the top of my head, so I'm just going to go ahead and solve it the old-fashioned way, and I might erase this if I need more space. But when we solve this, we do 6 times 5. That gives us 30. 1 times 5 is 5, and then we have our 3 on top that we have to add to it. We get 80. And of course, 3 times 3 is 9. Looks like I won't have to erase this after all. Now we need to see how many times 9 goes into 80. I know 9 times 9 is 81. So that's a pretty close benchmark to 80, but it's still larger. It's still greater than 80. So I need to go to the next lowest number, and that's 9 times 8, which is 72. So because 9 times 8 is 72, that means I have 8 groups of 9 that can potentially fit into 80. So this 8 right here, these 8 groups, that's going to be where I get my large whole number from. And then because my answer is 72 and you have to add 8 to get to 80. That's going to be my numerator in my fraction. So I'm going to get 8. And my denominator is going to be my original denominator, which is 9. And that, of course, our denominator is this number right here. And that's going to remain the same. So our answer is going to be 8 and 8 ninths bushels of blueberries. That's how many they picked. They picked on Sunday, and that's how you solve this problem, guys. And if you look at our answer, it makes sense because 8 and 8 ninths is larger than 1 2/3. And of course, if you kind of think about 1 2/3, and you kind of think about 1 2/3 times 5, it's probably somewhere around 7 or 8. If you kind of think about that in your head. So this is probably a pretty reasonable answer, and this is an example of how you might solve one of these problems today on your lesson.